gentlemen, thank you for the organizers for giving me this opportunity. It's great to see you all again. So, I am Kishan Thodkar Sundar Ramesh. Kishan Thodkar Ravindranatha Sundar Mahesh Thiruvananthapuram. Even I'm struggling. So, if you're wondering where I am here, that is me and that is my dad. All of my ancestors are back here. And, so, the title of my talk is basically, can really small things deliver? If you're wondering what this is all about, let's just find out, shall we? So, a common bias. You might think that this little guy here might lose against him, but no, what if he's a junior Jackie Chan and you could get it from the left side or from the right side, or maybe from here to there, or even on the bottom there? I don't know. So, remember the story of David and Goliath? In some cases, being small works even much better. So for instance, the story. Present times we're living in a fascinating journey. You know, the present day computing, the communication, or the healthcare is also fancy. Back in the days, this wasn't the case. Let's just ask all the time, why, and why? So a long time ago, ENIAC, or the first telephone, looked like this. For instance, the ENIAC was nothing but a huge calculator. So it had close to 5 million hand-soldered joints in them. I mean, ENIAC was so big, you could fit 2 or 3 Indian full-grown elephants in there. So these are all extraordinary feats, but it's just that they were super bulky and not less compact. So present day, so we went from ENIAC to this little Intel Nuke these days, which is super small. If you're brave enough, take precautions, and if you open it up, you see something like that. Now if you focus on the processor, which is as big as a 2 franc coin, and then zoom in maybe 10,000 times more, you see something so-called, these repeating structures, so-called a transistor. So these transistors are made of something called as a silicium, and silicium is apparently 28% of the Earth's crust. So in short, miniaturization, making things smaller and smaller has led to things what we are enjoying these days. So you might ask, what is a transistor? So just think of it as a tap. So as you know, tap has 3 conditions. You don't touch, it just stays like that forever. And then if you touch it a little bit, you get some water out. And if you touch it more, you get more water out. Okay. So now what is a transistor? Is basically, it's the same. It's an electronic transistor. Instead of the water, you have now current flowing in and out. Boom. That's your transistor, ta-da. Okay, so what's the idea, the real deal here? So you take a transistor, which is a 3D object, it has a length, breadth, and a width, and then now you make a microchip out of it. For instance, the latest Intel microchip has close to 5.5 billion transistors in it. I mean, it's like 2 times India's and China's population put together. So that's freaking a lot. So now, if you would ask, can we make it much smaller and much better? The answer is surprisingly yes, but with new type of materials. Some of them are like so-called graphene, which is just a single sheet of carbon. And if you roll that up, you don't get a joint, but you get a nanotube. So graphene is only 0.4 nanometer thick. You could ask, what's a nanometer? Okay, so on this scale, if you compare our human hair, which is close to 100 micrometer, and then our DNA, which is a nanometer, then DNA is 100,000 times smaller than the human hair, which is basically a nanometer, super small. Okay, so what's so awesome about graphene? I mean, it's only 2-dimensional and it's only 1 atom thick. It's the thinnest shit ever. So you just take a graphite, piece of graphite or graphene in German, and then you just use a scotch tape, and then you can, if you're lucky enough, if you do it right, you're gonna isolate the world's thinnest material, and for which these gentlemen got the Nobel Prize, and now the European Commission is also funding these projects. So graphene is 100,000 Mal dünner als ein Cent Frankennote. Thank you God for helping me say that. So graphene is much in such wow. So what's more awesome about graphene is basically awesomeness number 1. Now if I make a tap of graphene, and then if I look at the speed at which the current flows from right to left, it's as if I'm comparing Bugatti Veyron versus Cinquecento here. Or Rossi on his Yamaha versus me on a bicycle. Meaning graphene is super freaking fast. So what are the other more awesome things that you can do with graphene is basically a lot of things. For instance, flexible displays, microchip, Google Glass enabled contact lens, although I don't want to wear that. But you can also make transparent displays here. So you can also make sensors, batteries, blah, blah, blah. Surprisingly, you can also make a graphene condom, because literally nothing can pass through graphene, that's why, if you know what I mean. So how do you mass produce graphene now? So you could take a piece of copper foil, and then use a carbonaceous gas, heat it up, and then you can mass produce a lot of graphene as big as this. I mean, I'm not a graphene dealer, but I have some. If you need, we could talk backstage. It's okay. Okay, graphene can do this, graphene can do that. Can it make you a sandwich? No, there are limitations. Okay. So, no, yes. So in conclusion, you might think that this little guy would lose, but in another scenario, for instance, in the case of graphene, which is almost just the thinnest sheet ever, you can make so many beautiful things out of it. In short, even the smallest of the smallest things can deliver. Graphene can. Now, I love graphene so much, so I wrote this prose, and I'm going to sing it now, and then dedicate it to all of you, so it's a wrap. Okay? So let's go. As soon as the beat drops, we got sweet spot. It's time for the G to hit the spot. Unmatched accuracy, there ain't no bureaucracy. Science aligns with the lines. And new materials, G plus D. We're talking 2G. Nothing in the sea, nothing in the sea. Easy breezy. Charges flowing like a landfall. Through the streets of all the new age gadgets. Budgets tumbling and rolling, graphics popping, champagne, pop and pop off, and charges jumping and deflecting and reflecting, magnets constant, constant, breezy, reaching, quantum resistant. The measurement of persistence and existence in all its dominance. Small in size, still first prize, also wide with no disguise. So all I need is some hot burgers and some delicious fries. Peace out, thank you.